I thought I'd make a short video about something I was working on. More and more people are out there thinking of living off-grid these days, and the necessity for electricity is pretty high, or the dependence on it certainly, especially when it comes to things like boiling a kettle or charging your phone. Just useful things, little things out there, laptops, etc. So I'm building a power pack, and the power pack is recharged by solar, runs off a small 12-volt battery. I'll put all the items I've used in the description down below, so you can have a look for yourself. I won't put any of the sellers I got them from. I got everything from eBay, essentially. So you can knock yourself out looking for the same stuff if you like, or find better. Completely up to you. The idea behind it was, I've seen packs like this for sale for hundreds of dollars, and you can do it for so much less. But fundamentally, what I'm trying to show you is that it is possible to live off grid, even with a tiny thing like this. The idea, if you just scale it up, is what essentially you'd need to run your house. And I'm going to pause there, and I'm going to move the camera down to... So here we are, a video now of my gut and my desk, but I'm just going to run some of the parts past you and just explain very briefly what I'm going to do with it, and that's it really. So, a 12-volt battery. It's quite small, weighs about 2.5 kilos. You'll have to excuse wire on things. I've been tinkering and testing and that sort of thing, so everything works, and that is a 12-volt battery. The idea being that if I want to expand it, I could put another battery alongside it and run it in parallel. If I wanted to increase the voltage, I could run them in series, and then you'd have 24 volts, or if I run it in parallel, I can make my 12-volt system with a hell of a lot more sort of oomph to it, or a better reserve of power. If you need to know about series and parallel, I'll put something at the very end just to show you briefly how that works. Okay, on to the next part. The next part is a charge controller, very cheap. This goes from the solar panel to the battery, to a light output, but I'm not actually going to use the light output on this one. When it's all plugged in, it'll all light up like a Christmas tree, but we'll have a look at that afterwards when we're plugged in. Okay, the solar panel, the key piece to the whole thing. Cheap solar panel. This was $19.99. I started making my own and it would have cost me £18, so I thought, hell, for the sake of an extra couple of pounds, someone else can build the bugger for me, after burning my finger all over with solder and that sort of thing, which I'm not particularly good at. It also comes with some useful things like some crocodile crypts, and it's all set up ready for you. So a useful bit of kit. I would recommend, if you can find some cheap ones, get someone else to make it for you. Making them is not easy. Another little bit I bought is a battery power meter. This gives you how much charge is on the battery. I'm not convinced this is working properly, in all fairness, but I'm going to piece it all together anyway. And this is the other part. This is the output part. What we've got here is a car cigarette lighter socket, as you can see in there. So 12-volt systems can run off that, anything which is DC, direct current. And the other part is USB, useful in this day's and age to have a USB. The wires I've put on, I've put various bits on it to make my life easier. And right, I'm just going to reel back. And I'm going to chop and hack it all together, apart from the solar panel, put all the electronics in here, which is an old tool case. This particular case belonged to a sander, I think, something like that, but I'm going to hack it up anyway. So you probably won't see me hacking it up, because that's just an axeman job and won't be that interesting. But when we see this again, hopefully it'll have lots of nice holes in it and everything will fit nice and snugly. Okay, so we've seen all the parts. Let's put some stuff together and let me show you what I mean. Right, battery, live cable, and the negative, positive and negative. Positive and negative to the battery. Here we have the charge controller, which I showed you before, and you'll see the battery is in the middle, so positive to positive, negative to negative. It's as easy as that. You'll do. And when we plug Mr. Negative in there, we have life. That's just showing the state of the battery at the moment. It's a relatively new battery. I've had a play with it. I boiled a kettle from it and I charged my phone, so all well and good. What I would do with the solar panel, it's 8:05 in the evening here in England, so there's not a hell of a lot of sunshine in all fairness, but what I had was 2 cables going, which will be for the solar panel, and positive and negative, and when they're clipped on to the solar panel, the charge light comes on, and there's also a small load light which comes on. Okay, so when we're all set up and I'm doing a few more tests outside, I'll go over that bit again, so fear not brave watchers. So anyway, the next part is the plugs. The plug sockets, as I showed you before with the USB. The output on this charge controller, the light socket, is only about 1.5 volts. If you don't believe me, let's have a quick look. That's 1.6. Okay, and if I go directly to the battery, we can see that's 12.2. So you can see that the output to the light sockets really isn't a fat lot of use to me at the moment. It's yeah, it's pretty flimsy. I think I might hatchet up an old solar light set I had outside, which would probably run off that. Who knows? May or may not put it in the video. But so what I'm going to do is my sockets, which I've got, I'm going to put them directly onto the battery cables here. Luckily, I put little sort of electric forks on there, and they can slide in with a screw. So I'm just going to do that quickly and just slot it underneath. I should be probably humming some waiting music for you guys, but I bet anyone I can think of is the girl from Ipanema. There we go, we're done. Okay, there we have a battery and a 12-volt system connected to my USB and lighter socket. You can see the USB lights on, so the power is going through it. You'll have to trust me on this. When we've all set it up, I'll show you some charging. I'd quite like to run it completely down and then see how long it takes to charge up as well, which would be useful information. Just for little things, just to know if I'm at if I ever go camping, for example, with this, or I'm at a festival or something like that, then hell, I can just charge up stuff when I need to. Okay, so that in essence is what we're going to do. Okay, so here we are. I'm part way through the build. I've chopped and hacked. And good thing about these toolboxes is the inside's quite soft plastic, so where you need to cut, you can just cut with a Stanley knife or some sort of box cutter. What I've done is I've got my charge controller here bolted on. I'll explain what I've done for that in a second. There's 2 bolts going through here, and I'll explain what I've done with these curly wires here. They're going to the solar panel, these curly wires. I could probably have used a lot less wire, but hey, who knows. Battery charge meter is here through to the other side, and my 2 power 12 volt and USB are here. I've cut a chunk out here which is for the battery, which we can pop in now. The reason why I'm putting the battery in this way is when it's all closed up, the terminals won't be bending or pressing on anything. So let's plug the battery in. Hopefully you will see stuff light up here. The charge controller has just lit up. You probably won't be able to see that, but I'll show you after I put the battery how I want it. There we are, lights still on, still good. Cable management's one for the future. Good thing about this case is I realised when I was looking at it and placing things, I thought, do you know what, I can fit another battery vertically here. So if I want to make this either a 24 volt system, which is unlikely, I'll probably keep it as a 12 volt system and maybe put another battery in here to run in parallel with this one. So anyway, there we have. Let's show you the battery light. If you can just see that, let me shift the cam for a second. See the light on there saying that the battery is hooked up. And let's close the case up carefully. It's a bit of a jungle in here at the moment, but we'll sort that out in a second. So closing the case. Some clips at the front. Do you remember I said the charge controller had bolts going through? I didn't see any reason why not, but I've put the solar charging wires to these bolts going through, and put another nut just between the plastic and the screw type head, and this way when I want to, I can plug the clips from the panel onto this extending nut that's out there, or extended bolt, and then negative is down there, but that's up for me to strip the wires out, and that way I don't have to open it all up and that sort of stuff. I can just clip it to it. So that's what I've done here. Other things I've done is my ports here. Hopefully the USB light is on. Yep. I've just the one reason I chose a plastic, one reason I chose a plastic case is you can cut this very easily. I didn't use anything but a drill and a Stanley knife, or a box cutter basically. A bit of a mishap there. See how easy it is to cut, but a bit of an air hole won't kill anybody, especially because there's a lead battery there. So there's my USB, my battery meter. I'm not sure why this isn't doing anything. I may have to sort that out at some point, but if I do replace it, then I can just whip it out and put another one back in. So there we are. That is reasonably portable. It's pretty light, you know. Even in a sort of case form, it's pretty handy, and it's got these clips to open it and close it. I may do something about these and make it more secure, but essentially that's what I've done. What I'll put on is a bit of charging when it's daylight, and we'll have some things going off it and see how we get on. But that's it, really. As easy as that. And yeah, quite chuffed. It's all right. just cutting into this part. I've made some alterations to the power pack. I guess it needed some tweaking. I've added another battery. I've also added a one-way diode. So I noticed, I think a lot of the battery power was actually leaking out of the solar panel, or I needed a one-way diode. I'll show you in a minute. At the moment, the reason why I upgraded it, the main reason was I bought a travel kettle which I was using to test it, a 12 volt kettle, but it would sap so much of the power boiling the kettle that it just needed another bit of juice in there. Otherwise you couldn't do anything. I also built some other things which I can show you as well to go with it. One was sort of a 12 volt light on a huge cable. I'll show you that as well. At the moment I'm just boiling the kettle, so I'm going to cut away while this is boiling, and I'll tell you exactly how long it took it to boil as well, so we'll get a good idea, and then I'll show you inside the box and just show you some of the upgrades I made, just so you know that this is what I did to this box to get it to where I think I wanted it to be to travel around with. Okay, I'll cut away and I'll be back. And we're back. Okay, so what I've done is I've left the kettle on. About 15 minutes has passed since I plugged this kettle in, and now we have hot water. I'll just hold it over there. I'm just going to open it up. There's not much of a boil going on, but it's boiling. If you turn the camera around, it's certainly steaming up the lens there slightly, and you may not be able to see the bubbles, but it's pretty hot, that water. And you won't see the steam. No, you can't see the steam. But yeah, 15 minutes for that kettle, and it is about half full of water. If I just give you an idea of scale, it's not a particularly big kettle, but we've got some very hot water in there. It's certainly good enough to make tea or coffee or something like that. But essentially it's just to prove that the power pack will get the job done. Right, I'm just going to move this over here and then show you some changes I've made to this, because they're quite important changes, and I think if you're going to do this yourself, I think you may need to go along the same route as this. But yeah, let's pack the kettle up, and it's just a 12 volt jobby. Comes with plastic cups and all sorts of jazz. It's quite interesting. Okay, so you probably remember this from before. What I've done on the outside is I have added a power switch and for the whole thing, and we'll turn it on. I'll leave it on actually so we can see some bits. Nothing's changed on the front. The battery meter is working. As you can see, we're a bit low on the old power. The kettle seems to absolutely vampire everything away from it. But anyway, let's open her up and I shall show you what I've done inside. Okay, if you remember before, we had I think I had it round the other way when I was showing you guys, so I'll just flip it round so it's the same sort of way. This is our original battery we put in. This bit of tape simply just to keep wires out of the way. This is the other battery I've put in. I've cut it into place, but everything's fairly stable in there. I've got some cable which I could run over the top to stop it running around, but it's fine. There's no problems with it. Mind you, I haven't been running with it or anything. And this is our charge controller which we had before. It's a bit of light. This is our power indicator. These are our two plugs, and this is my on and off switch here. And there's one thing I've added, apart from generally tidying up the cables, and this is a one-way diode. So to the solar panel and from the charge controller, this just makes sure that the electricity, give or take a volt, which I've noticed, is only going in to the system rather than out. So it's there's no leakage, which I noticed there was generally a bit of leakage out there. This diode means that when I've run it completely down on the kettle, mainly it charges up much faster. It's not losing any power through the solar panel, which I thought the solar panel came with a diode, but I obviously misread that or imagined it, and it doesn't. And all the diode is sorry about that. You may not be able to see it, but it's just a small fork type thing you'll see there, and it just puts the flow out. I wanted these anyway because I was going to adapt to an old drill to see if I can get that, an old low voltage electric drill, see if I could get that to generate power as well. So I wanted one of these anyway, and it came in a pack of 2, so obviously when I call it, I've just whipped it in there. And actually, all said and done, I can probably just, I don't need another one, I only need the one because I'll use the same method of attaching it to the outside. Okay, I wanted to show you these upgrades because I think they're quite important. The extra battery is a must. These small alarm batteries which I've got, which are the sort of lead acid batteries, they're pretty old tech, and there's some amazing lithium ones out there which, although they cost a bit more, they have so many more amp hours, and they're slim and they're trim. But yeah, I wanted to make it clear that actually my original design of 1 battery needs to be 2, and you definitely need this one-way diode. Again, it'll be in the description of what I've bought, so the name you can see on there. Okay, I'll just clip her all back up again. Another thing I pieced together was just a light. It's not very pretty at the moment, but it's you'll get the idea. And it's simply just a couple of LED strips, and it's on a fairly long cable, and it's got a power button on there. But it does generate quite a lot of light in a dark space. It's not bad. It's not bad at all. And that runs for ages. I've had this running for hours and hours and hours, and it doesn't seem to make a dent on the battery at all. They're fantastic little things. I've got another couple of these. I might attach a couple to the case, so there's another switch on there, and just so there's light if needed on the case. Okay, well, that pretty much wraps it up of what I've done with this. It's really basic, and as I said before, I only did it for fun, just to see if I could have a go with it. I wanted to mess around with the solar power, and the idea being that if we take it on a trip or something like that, then you can have hot water, or there's light in the tent, there's some other reason. And then ultimately the plan is that maybe in the future, in the pipe dream, that I can scale the whole thing up and have something that, you know, will effectively run a dwelling or a residence or something like that. And at the moment we have got solar panels on the roof, but they feed into a tariff at the moment, so they're not attached to a battery bank or anything like that. So there's definitely scope to do various bits there. But I hope you took something away from this, because if you suffered all the way through it, then you might have grabbed something. But okay, hopefully I'll make another one about the drill, and I want to adapt an old electric drill and get that charging as well and see if that works. But okay, yeah, thanks, cheers, bye.